this problem, we are going to use the second derivative test to find our local extrema for the following function if the test applies. Otherwise, use the first derivative test. For the first derivative test, when we find the critical value c, we locate it on the real number line and then determine whether the sign is positive or negative, and then see the sign change. If it changed from positive to negative, that means the graph is increasing one side and decreasing on the other side. We have the local maximum. If the sign change from negative to positive, the graph is decreasing and then change to increasing. That point gonna give you the local minimum value. For the second derivative test, we have to do two layers. First, find the critical value c, and then from the f prime equals 0, and then use the c for the second derivative to see whether the sign of the f prime at c positive or the sign of the f double prime at c negative. If positive, gonna give you local minimum. If negative, gonna give you local maximum. So let's start with the second derivative test as the instruction provided. So part A, f of x equals 8/3 times x to the third minus x to the fourth. The first derivative of the f is 8 times x squared, and then minus 4 times x to the third, where the second derivative is 16 times x minus 12 x to the second. To find the critical value, f prime of x equals 0, or 8x squared minus 4x to the third equals 0. Factor 4x to the second out. We have 4x squared times 2 minus 1 times x equals 0. So we have two critical values, x equals 0 and x equals 2. For the second derivative test, we're going to check the sign of f double prime at 0, which is 16 times 0 minus 12 times 0. It's 0, so the test fails to determine about the local max, local min. Next, f double prime at 2 equals 16 times 2 minus 12 times 2 squared, which is 32 minus 12 times 4, which is 48. The sign comes out to be less than 0. If it is less than 0, not really happy, like open down like this. So the point x equals 2 will give you the local maximum. And the function value at 2 equals 8/3 times 2 to the third minus 2 to the fourth power, which is 8/3 multiplied by 8 minus 16, and it turns out to be 16/3. As the order pair 2, 16/3 is the local maximum point. If we use the first derivative test, just draw the real number line. For the first derivative, we have 0.0, we have 0.2, and we're gonna determine the sign for x squared 2 minus x. On the right side of the point x equals 2, for example, 3, the sign gonna be negative. Between 0 and 2, for example, if x equals 1, the value gonna be also negative. No, positive, sorry. And then less than 0, for example, x is -1, the sign going to be positive. This way we can see that the graph increasing, and decreasing. Only one point that gives you the local maximum by the first derivative test. which is the same result as the way that we use the second derivative test.